And welcome, everybody. It's fantastic to have you here on this beautiful Pacific Time 4 p.m. afternoon stream. My name's Keith Barker. If you're brand new to the channel, holy shnikers, I'm glad you're here. I'm having a bunch of fun in these live streams, and I'm always amazed at the adrenaline rush I have, which is like near panic attack, like 5 minutes before it starts. So that's done. That already happened. So I was getting out of the shower and I have my cell phone. I'm playing the countdown timer and that music's going. And I'm thinking, oh my gosh, we're going to be online here in a few minutes. But you know, when I get here, it's fantastic to join you. And our topic today for this live stream is why routes have to win twice. And let me give you a big picture, and then we'll talk about the details, and then we'll demonstrate it in the lab environment. For a route to make it into the routing table, it's not just a walk in the park, an easy day. I mean, there could be, imagine that we have a router and it's got 4 or 5, let's use an analogy. Let's imagine that we have 4 or 5 friends that are telling us what we should do. They're giving us their opinion about what we should do. And if their opinion differs, like one person says do this, another person says do that, and third person says do something totally different, there's a decision that has to be made, like, well, okay, what are we going to do? Are we going to follow this person's advice or that person's advice or none of them? The same kind of a situation happens with a router. A router can learn routes in many different ways. It can have a directly connected network. So if we took a router and took its interface and said, dear Mr. Interface, no shutdown, bong, and it's up. Great, the interface is up. And then if we said, your IP address is 10.1.7.7 with a 24-bit mask, it then realizes or believes that it is on the 10.1.7 network. And so as a result, there's a network there, and that a directly connected network has an administrative distance of 0, which means pretty good. It's like golf. The lower, the better. But if we have other route sources like static routes or routing protocols that are advertising routes to us, if we're getting advertisements for a specific route, let's imagine a 24-bit network. Take your pick, maybe 10.10.10, whatever it is. If we have multiple routing protocols or options for learning that, the way we were going to determine which one we're going to put in the routing table to even be used possibly later is by administrative distance. It's like golf. The lower, the better. So you're saying, Keith, that if I have 2 different routing protocols and they're both advertising to the single router, 10.10.10, that network with the 24-bit mask, that the routing protocol that the local router considers to have the lower administrative distance, like OSPF is 110, EIGRP is 90, RIP is 120, whichever has the lowest administrative distance, that's the one that's going to get in the routing table. And that's it. So part of the pecking order of the game that a router is going to play is making sure it chooses the route that has the lowest AD, administrative distance, and it's going to put that in the routing table. Now, the next question might be, well, what if we have the same routing protocol, like OSPF, it has an administrative distance of 110, and we're learning about the same route twice, but they're from different environments. What do we do then if they're both administrative distance of 110? The next tiebreaker, if we're learning about the same exact network, 10.10.10, and it's a 24-bit route, and we're learning it from 2 different sources and they have the same administrative distance, the tiebreaker then is the metric or the cost. So that's the little number that, when you look at a routing table, has the administrative distance first, then a slash, and then the cost or the metric. And so if we're learning about 2 different routes, like having 2 friends that tell us, hey, here's what you should do, and they're both differing information, do we believe them both the same? If the answer is yes, maybe they have the both same administrative distance. And then we look at the second factor, which is cost. How painful will it to be what you say versus what you say? And in a routing table, we want the best possible routes to show up. And so the one that has the lowest cost or metric, depending on the routing protocol, with OSPF, it's cost. With things like RIP, it's a metric, or it's a hop count. So the one with the lowest cost wins. And that's it. That's how we get into the routing table. Now to demonstrate that, I thought we'd go over to the whiteboard and take a look at a topology and actually see it in action. Let's take a look. So on this whiteboard, I've got a lot of routers. There's probably too many for this demonstration, but we got looks like 8 routers here, and we've got this network right here, which is 10.1.7.0. That's off of gig 00, and router 7 is directly connected to it. So what I would like to do is, first of all, add. Now this is something you probably don't want to do, too much in a production environment or even practice too much, but I think we had to use RIP to begin with. And RIP is a routing protocol. A routing information protocol is the acronym. We'll use RIP version 2, and I'm just going to put it on all these routers, give it like 2 minutes to converge because RIP isn't that fast. It's a distance vector routing protocol. It's no longer on the CCNA, but it'll do for our demo because it has an administrative distance of 120. So if router 8 learns about that network, 10.1.7, with RIP, it's going to have an administrative distance of 120, and in absence of a better source of information about that one network, it's going to put that route that has the administrative distance of 120 in its routing table. And then what we can do is we can actually use a different routing protocol that has a better administrative distance and then see those routes bounce out. So let's do that first. And let me clear this up. And let's go ahead and bring up a command line. And this almost looks like a command line. And now it does. Now, one of the secrets that I think is really important is that if we're doing repetitive tasks over and over and over again, it makes sense for us to automate that. So if we had scripting or a controller, we could use APIs and communicate it all at once. But short of that, let's use Notepad and just put in RIP on all these devices just so we can see that R8 on the far right-hand side of the topology is going to learn about that network. So I'm going to bring up Notepad. I've got it right here handy. And some of the commands, think about what are some of the commands we'd use to configure a router. Now, if you're brand new to Cisco, at the CLI, we'd type in configure terminal. But the cool kids, they just do config space T because it's unique enough and the Cisco router knows what it means. So config T or config terminal, it basically means I want to configure from the terminal I'm sitting at. Great. So then if we're going to do RIP, we'll go into router configuration mode for RIP. So we'll say router RIP. When I think of RIP, I think of Astro on the Jetsons. That was a cartoon from like the 70s. And router RIP, George. All right, so router RIP, that puts us in the router configuration process. And then let's do a no auto summary. So by default, RIP summarizes the classful boundaries on class A, B, and C addresses. So that's just so it won't behave that way. And then we'll also say we want to run version 2 just because version 1 blows chunks. Just to be clear on what I was meaning there. Version 1 doesn't advertise masks, and so you can't use variable length subnet masks with version 1. And so we'll use version 2, and then we'll use a network statement. And this network statements are classful, unfortunately, but what this network statement means is, please, Mr. Router, any interfaces that have the 10 network on them, please enable them for RIP and share those routes inside of the RIP routing process. And that's it. So we'll just go ahead and copy all that with a Control-C and go to router 1, paste it in, check for typos, and then we'll just put it in all the other routers. I'm just clicking on each of the tabs and right-clicking in the console to paste them, and we are good to go. So in a few moments, and it might take a few minutes, we are going to have full convergence between all these 8 routers, and distance vector routing protocols like RIP version 2 aren't very smart. They periodically just say, here's everything I know. Here's everything I know to their neighbors or to whoever happens to be hanging off the network. They don't form formal adjacencies. They just burp out their information periodically. And eventually, the whole network will converge. So I think I've stalled long enough for RIP to converge. Let's go take a look at router 8. So the trick here is, or the goal here is, I want these routes here from router 7, that 10.1.7 network. I'm waiting for it to show up over here on R8. So we're going to focus on that one specific 24-bit network in our demonstration. That'll make it easier to see the network change and focus on one address versus like, oh, there's 20 networks. We just focus on one at a time, and that makes it easier to troubleshoot and also to learn. So let's go back to the CLI, and let's do a show IP route, which will show the show IP routing table on the Cisco router. All right, looks like we're fully converged. This is show IP route. And if we want to see just the routes that were learned via RIP, we can do a show IP route and tag on the keyword RIP. And that will just limit the output. Doesn't change the reality of it, but limits the output to just showing us the RIP learned routes. Fantastic. And if they're all 10s. So Another thing we could have done is do a show IP route for 10.0.0.0, and that will show us all the 10 anything routes. But because that's all we have here in RIP, it wouldn't really limit our output. So here's our network right here. And this is R8 telling us, "Dear Mr. Administrator," as he gets out his pen. "Dear Mr. Administrator, I learned a route via the RIP routing protocol." That's what that R is on the far left. The decoders, the codes are up here on top. "The network is 10.1.7 with a 24-bit mask. That's the route. I learned it via RIP, and I assume," says the local router, "that the administrative distance for RIP, any RIP learned routes, is 120 by default. And with administrative distance, if there's two different sources advertising the same route, the one with a lower administrative distance is going to be preferred and put in the routing table, and the one with a higher AD wouldn't." So it's like, I got to struggle to get in. And now we have no competition because we only have RIP running. This 5 right here is the metric. That metric is going to vary just a little bit based on the routing protocol you're running. In the case of EIGRP, we'll focus on RIP. In the case of RIP, it's a hop count. It means how many routers do I have to go across to get to that destination network. And so if I had 2 advertisements for the 10.1.7 network and they were both from RIP, and one had a metric or a hop count of 5 and one had a hop count of 7, I would put this one that we're looking at in the routing table because it's a better route. So administrative distance first. If it's a tie, then cost or metric. And then if it's a tie and we have 2, we'll put both of them in because we're going to say, well, 2 routes there have equal AD, equal cost. Let's put them both in. We'll take a look at an example of that on R4 in our topology in just a moment. This is also indicating that the next hop, if we ever need to forward a packet, says R8, to get to the 10.1.7 anything, we are going to go ahead and forward it to our good buddy 10.2.68.6. And we are going to use the egress or exit interface of fast Ethernet 4/1. So that's what all of that means. And we say fantastic, and then we want to try it. So we could do a trace to 10.1.7 I'm going to pick up my notes here. Okay, .7 is the address right here off of R7. So we're sitting here at R8, and we're doing a ping or a trace, whatever we're going to do, all the way across. And here's what I would expect to have happen. I would expect that R8, let me use a temporary color for this so I can easily erase. I expect that R8, we already saw his first hop is here. And then R6 is going to make its own decisions based on what it believes to be true about forwarding for that network. And so it's also going to forward this direction. But when we're doing IP routing, it's hop by hop. It's like hot potato. Each router takes the packet, figures out what the next hop is, re-encapsulates at layer 2 to put the next hop's layer 2 address on, shoves it out the door, the exit interface, the egress interface, and then the next router gets it, sees the layer 2 address, its own address, looks at layer 3 header, and says, oh, this is destined for a certain network, looks at its routing table, makes a decision, and that continues on. So here's what I think is going to happen. I think that the routing is going to go like this, unfortunately. And I'm saying unfortunately because this yellow link right here is fast Ethernet. So the high road across the top is gigabit, and this is fast Ethernet. But from a RIP perspective, all it is doing is counting how many routers do I have to go across. So here it's going across R6, R4, R3, R5 to R7, and we'd have an additional router, actually an additional 2 routers in the path if we took the high road. So, you know, distance vector routing protocols that are just plain Jane like RIP version 2, they're not getting a lot of love these days because they're not helping us out using our most effective paths. But that's what we expect the path to be, and we can verify that with a quick trace. So we'll go back to the CLI, and we'll do that. So trace to 10.1.7.7, and I think I have a host PC7 sitting off there at .10. Yay! So PC8's out there as well. And so PC8, if we took a look at PC8, that's its IP address. So we could do a trace to 10.2. Oh, we're on PC8. So on PC8, we do a trace to 10.1.7.10. What that is, I believe, that is the IP address of this PC over on the far left. So this is PC8 on the far right, doing a trace all the way across to PC7 just to verify true end-to-end connectivity. Yep, fantastic. So this part right here, destination port unreachable, When we do a trace from a Cisco router or from a Linux box, it actually at the layer 4 uses a UDP header. And so it's looking for some port. And when it hits the final destination, if that port isn't open or the server's not listening on that port, it says, I'm not listening on that port. And so that's why this message is coming back. We also have options in some applications and some software to do traces or do a trace and implement a TCP-based trace or an ICMP-based trace. So Windows, by default, will do ICMP as its trace, like a ping, instead of UDP or TCP. Also, it uses the TTL. So it basically is tricky. It sends out the first 3 packets with a TTL of 1. The first router in the path kills them. And that's why we get those messages back saying, hey, I killed your packet. And that's what happened here with the first path. And then we sent it out again, the PC did, with a TTL of 2. And then router 6 killed the packet and sent us the 3 messages. And that's what we're measuring when we come back, is the I killed your packet messages from each of the routers in the hop based on the expired TTL. So that's the magic of traceroute, which is a fantastic tool. All right, so that is RIP in all of its wonder. And now that we have RIP and R8 has learned about the 10.17 network via RIP, let's go ahead and use something better. So something better would be almost any routing protocol. We could use EIGRP, which has an autonomous, which has an AD, an administrative distance of 90. OSPF, which has an administrative distance of 110. And either one of those is going to beat out RIP, because RIP, if we do a show command again here on R8, I'll just scroll up a little bit, for that 10.1.7 network, come on you, all we have to do is beat 120. So let's do OSPF, because that's a CCNA topic, and that'll give us a little practice with that. So let's go ahead and configure terminal and router OSPF process ID 1, and then we'll specify network 10.anything, and then the wildcard mask that says we care about matching on the 10, but we don't care about matching on the 2nd octet or the 3rd octet or the 4th octet. And Mr. Router, once you've had a chance to look at all your interfaces and see which interfaces begin with 10, we want you to put any interfaces and any directly connected networks to those interfaces in area 0. I think that's really all we need. So I will go ahead and copy that, and let's pump it into each server. There's 1, 2, 3, 4, 5, 6, 7, and 8. Now, it may take a moment for OSPF to figure out the DR, BDR situation and have full adjacencies, but once that's up, it's going to be very quick. In fact, let's do this. Let's have a little fun. You want to watch the RIP routes die? Debug IP routing. This is a winner, by the way. In my CCIE lab, this saved my bacon more than once. So debug IP routing is going to give debug or log messages and debug messages anytime there's changes to the routing topology or the routing table on the router. So as the OSPF neighborships come up and we start exchanging LSAs and everything's converged, we're going to have routes learned by OSPF. There they go. We're going to have routes that are learned by OSPF that have a better administrative distance, and we'll see the other routes being pushed out. In fact, let's see here. Let me just give it a few more moments to converge completely, and then we'll look at some of the output. That'll do. Undebug all. Look at this. That's our route. It's like I was going to search for that. I was going to search for that network, but a few moments ago, that route was in router 8's routing table as a RIP learned route with an administrative distance of 120. And now what this debug is showing us that, hey, we have a closer, meaning better, administrative distance for 10.1.7.0. We're flushing one route. That's the old RIP route that's being flushed out, and the OSPF learned route is being put in. It's a jungle out there. You know, the routing table, competing to get in. And this helps demonstrate that the way a route gets into the routing table, if there's conflict for the same exact network, the conflict is going to be solved by taking the route that has the lowest administrative distance. And that's the route that's going to come in. Now, there are some defaults that we should be aware of for admin distance, and some of those defaults are A directly connected route has an administrative distance of 0. I mean, that's a pretty low golf score. If you've got a golf score of 0, probably somebody's cheating, right? Because you have to hit the ball at least once. But that's what the default is. And then if we have a static route, and I'm going to clarify that because later in CCNP and CCIE, you'll want to know this. If it's a static route that has an IP address as a next hop, then the default administrative distance for that is 1. Because you can have a static route that's actually pointing to an egress interface, like on a point-to-point. You can do it on Ethernet too, but it's a bad play. And then that would actually be seen in the routing table as a directly connected route, even though it's a static route. So a typical CCNA static route with a normal next hop is going to have a AD of 1. And then as we go down, let's take a look at some others that are going to be EIGRP. It's not on the CCNA, but that's okay. You're still going to see it in some production environments with specific applications like DMVPN with an overlay of EIGRP. But anyway, it has for interior EIGRP routes, there's an administrative distance of 90. And then next we would have OSPF. I'm just using ones that are going to be most popular. Would be 110. And then RIP would be 120. And if we're talking about border gateway protocol, external BGP routes would have an AD of 20 by default, and internal BGP neighborships that we're learning BGP routes that way, that would be 200. For CCNA, not too important. These would be, I think, more than enough that you need to know for CCNA. Now, these are the defaults. You don't have to use these defaults. You could go into a router and simply say, hey, dear Mr. Router, from now on, I want all OSPF routes to be considered an administrative distance of 70 or 90 or 250, whatever number you wanted to put there. So these are the defaults and good to know. So let's go ahead and we just watched OSPF beat out RIP. The debug actually explained that or gave us a visual representation of that. So let me hit the right button here and let's take a look at the routing table. Just show IP route. And there's our 10.1.7 network. So there's the administrative distance first, 110, which is the default for OSPF, followed by the metric, which in the case of OSPF is cost. Oh, you know what I did wrong? I mean, yeah. I forgot to put something in pretty important. Let's look at our topology and bring up a pen. So with RIP, R4, if R4 was going to try to get to the 10. I think this is 10.0.1 network up here, RIP would have seen, and I didn't show you, we just overlaid OSPF on it, but it would have seen this path as equal cost because it was 2 hops away going on path B and path A. And I think we've seen that before in a previous stream. So RIP is not that smart, but OSPF, because the reference bandwidth is 100 megabits, let me take my face out of this, because the reference bandwidth is 100 megabits per second, Mbps. Effectively, what that means by default is that every interface that's 100 megabits or higher is going to have a cost of 1. So with that older and default reference bandwidth, OSPF also sees this as equal cost paths. But you know what? That's perfect for our demonstration because I can show you how if the router believes that it has 2 equal cost paths, the admin distance is the same for a specific network and the cost is the same for a specific network, it can put both of those in the routing table. So let's do that. That'd be fun. And let's take a road trip up to R4 and then we can correct that also. So here's R4. We'll do a show IP route for OSPF learned routes. Yep, right here at the top, the 10.0.1 network. The admin distance for these 2 routes is 110. And let me go ahead and use a little option there. There we go. To highlight those. In a terminal emulator, you can hold down the Alt key and actually do sections that you want to highlight, and that's what I'm doing there. So for this route for 10.0.1, it's got 2 routes, and it's got admin distance of 110 for each, and it's got a metric or a cost of 3 for each, and that's because of the faulty reference bandwidth. I shouldn't say faulty, but older default reference bandwidth that still ships with Cisco iOS. So we can verify that with the show IP OSPF, press enter. And this is going to show us that the reference bandwidth right here is 100 megabits per second. So I need to fix that. I want to fix that. So we have one clear winner, and it's going to win because it has a better cost over path A than path B. So let's go into router OSPF again. We already put in the network. And let's use the auto cost reference bandwidth, and we'll specify 1000, meaning 1000 megabits per second. That way our gigabit interfaces will look like a cost of 1, and the fast Ethernet interfaces will look like a cost of 10, and then OSPF will have an accurate picture because it has all the LSAs, and it can build the best path through the network based on the actual costs of the interface. So I will go ahead and right-click, copy that, and go to R1. And it's warning me to make sure I do the same reference bandwidth across all devices in my network. And I am. All right. So now, if we go back to R4, which a moment ago, and I'll scroll up to take a look at the output here. A moment ago, R4 thought that for this network, 10.0.1, it thought that it had two equal cost paths, with R2 and R3 being the next hops, respectively. So here's R4 right here, and R2 and R3 considered to be equal paths either way. But now, with the auto cost reference bandwidth saying that, hey, gigabit has a cost of 1, but your fast Ethernet has a cost of 10, it's going to change its opinion. I'm expecting it just to have the fastest path through from R4 to R2 to R1, and not consider the slower path through R3, even though it didn't make it to the winners table. Now, the winners table is the routing table. So that's what we're looking at here, and we'll just do a quick up arrow key a couple times for show IP route for OSPF learned routes. And there is our new updated route for 10.0.1. And it's now just using the next hop of through 24.3, and that's because the other route that goes, this is going through 10.0.24.2. R2 is the next hop. And that's because the previous route that went through R3 over that fast Ethernet link is no longer contending. It's like, so sorry, you don't make it to the routing table. You don't win. All right. So we've taken a look at two options, or two examples of getting into the routing table. One with RIP, where there's no competition. Then we brought in OSPF, which had a lower administrative distance. And so those routes were put in the routing table. We did a debug to verify by RIP learn route. It's been nice knowing you. And then next, I'd like to share with you even a lower administrative distance. And I think an example of that would be using a static route. Because if we go to R8 and you and I put a static route on R8 for that same network, the 10.1.7, we'll verify that in the lab. If we put a static route and we just make the administrative distance lower than 110, it's going to win. So by default, a static route that has an IP address for a next hop is going to be a default, or it's going to be a static, it's going to have an AD of 1. But we can control that by tacking on whatever AD we want that specific route to use. So let's do that. And we'll go back to R8. Just do a quick clearing of a few things and just show IP route for OSPF learned routes. That's enough. There's our route right there. So 10.1.7, just to remember where we're at, that's this network down here off of gig 00 for R7. And we are sitting at R8 over on the right-hand side of our topology, just to make sure we're all in the same exact place. And what we're going to do is we're going to simply replace this, or add a static route that says the metric is, or the AD is going to be something less than 110. So we're going to go into configuration mode, IP route, and we'll put in 10.1.7.0 with a 24-bit mask. Just like that. We'll specify the next hop of 10.2. I'm using the same next hop because R8, between you and I, R8 doesn't have a lot of options. It's like, we could actually use a default gateway and point to R6, and that would be fine, because the only way R8's moving traffic to anywhere outside of its directly connected networks is R6. So we'll put in that next hop of 10.2.68.6, and then here we can tack on the distance if we want, the distance metric. By default, it's going to be 1, but we could go ahead and use like 109. Boom. And that would work because that's lower than 110. So we do a do show IP route OSPF for OSPF learned routes. And then we go down a little bit. I don't see it. 10.1.5. Oh, yeah, I just told it, please show me only the OSPF learned routes. I'm like, I don't see my route for 10.1.7. It's like, yeah, you told it not to. Computers, they do what you ask them to do, not always what you want them to do. Let's do a show IP route. I'll see the entire routing table that way, including the static route that just beat out the OSPF route, and that's right here. And that's because of the lower administrative distance. Now, check this out. This is fun. It's a little fun game. If we hit the up arrow key a couple times, and we add the static route again, but we change it to 111, which is a worse AD than the OSPF learned route, and press enter, that updates that static route. And now we have a static route with an administrative distance of 111. And if we do a show IP route and hit spacebar and take a look at that one specific route, it's now back to the OSPF learned route. If we did a debug IP routing, it would show us that swap. Say, whoa, the OSPF learned route is better than the static route, and it put it in the routing table. So that route that we just created with a artificially high AD, that's an example of a, what do you call it at Halloween? You've got those little ghosties that are going around. Floating static route. That's what it is. That's a floating static route is a static route that's in the config, but it's not in use yet until the primary route, for whatever reason, goes away, and then it's the next best option, and it will go into the routing table. So we have a floating static route. I'm going to go ahead and put it back as, let's go ahead and put it back as, how about a, well, we just press enter right here. Check this out. Now it's the default of 1. That'll work. I'm not sure why I had to think about that so hard. And if we go back now and look at it, here is our static route. And there is the administrative distance right there, which is 1. So 1 AD by default. Okay, so in our goal, in our journey today, we wanted to cover 2 things. The theory of why does a route have to win twice? It has to win once to get in the routing table. And that's all boils down to what options do I have as a router, what routes are being advertised or communicated to me, and if I have a tie for the exact same route, let me go ahead and use the one with the lowest AD, and it will go in the routing table. If I have 2 exact routes with the same AD, then it comes down to cost. I will put the one route with the lower cost in the routing table, and if they're both the same, they both go in the routing table, and then we can do multipathing and load balancing across, and the router can actually use both of those paths. Hopefully it's going to use consistent paths, and Ceph plays a part of that, but that's the general idea. Now, as a side note, just as a side note, and that is, if we're running a routing protocol like EIGRP, it has the ability to go ahead and do proportional load balancing on slightly different cost paths. So if an EIGRP router has 2 or 3 or 4 interfaces and routes, I should say, that they're not equal, but they're all feasible, meaning they can all be used without creating a loop in the network. We can actually configure unequal cost load balancing with EIGRP, so it'll use multiple unequal cost paths, and it can do proportional load balancing. But for CCNA, there's no EIGRP, so that won't come up. But just wanted to be aware of that OSPF and other protocols are going to do equal cost load balancing, EIGRP being a corner case. Okay, secondly, now, these routes have duked it out. They're in the routing table based on the lowest AD, and now which one is going to be used? This is a fun discussion. And it's pretty short too, but actually calculating it is fun to do, and that's what we're going to do. The answer to that is, if you and I are a router, and we see a packet coming in that IP header, there's no mask information in the header of an IP packet. It has an IP version 4 source address and an IPv4 destination address. And as a router, we're looking at, unless we're using reverse path forwarding or something, we're looking at the destination IP address, and we're going to make a forwarding decision for it. So we look at the destination IP address, and then we look at our routing table, and we look for a match. Now, there is an opportunity in a routing table to have one packet that matches against 2 or 3 different routes that are different lengths. It's true. I'll show you here in a moment. Which one are we going to choose? Which one does the router choose? And the answer is, it's going to choose the longest match. What do you mean, Keith, the longest match? I mean that if, it's sort of like, imagine that we were handed a package and we were asked to describe that package, and we had 5 choices. If we have 3 of those choices that describe the package, but one's the most accurate or most detailed, we might choose that. It's sort of like that with a router. When a packet comes in, if there are several routes in the routing table that match, that could be used, it'll choose the one that matches, that has the longest match. So that means a 24-bit network and a 25-bit network and a 26-bit network as a route. If they all matched, it would use the 26-bit network. The longest match in the routing table wins. Sometimes people forget that it's a very distinct two-step process. The first step is who gets into the routing table. Great. Once that's all settled and the routing table is stable and sitting there, the next question is which route in the routing table is used if there's multiple possibilities. And if none of the detailed routes match, does it mean we're going to drop the packet? No, because if we have a default route, that's where the default route would come into play. It's like the router's like, yeah, I just looked through, this is like computer hardware, very quick decision, but hey, I just looked at all my routes and nothing matches here as far as detailed routes. No 16-bit networks, no 12-bit networks, no 8-bit networks. You know what? I'm going to go ahead and use my default route, and makes a routing decision. Next packet, please. So even if we don't have a detailed route that matches, there could be if there's a default route on the router, it's going to use that to forward. So I thought what would be fun to do is let's create an environment where we have multiple routes that we can play with that would all match. And then I'm going to share with you how we can predict as humans, because it's important for the real world and for certification to be able to do this. I also will warn you that if you haven't been through the Subnet Saturdays with me yet, I would encourage you to check out that playlist on the my YouTube channel. And there's a separate playlist for Subnet Saturday. I've also integrated that as part of the master playlist for CCNA. Either way you want to consume that is great with me, but we are going to be using something referred to as block size in our calculations today, which was a couple Subnet Saturdays ago. So if you haven't yet gotten to that, give yourself a huge break and a huge margin, and come back to it after you've actually looked at that Subnet Saturday series. All right, so let's do this. Let's create some routes here, and it's saying, Keith, you got to create a new layer for that. I can do that. Let's go ahead and and give me one moment here. There we go. There's a new layer. Let's create 4 new routes on R8. And these routes are going to be 10.1.7.0/24, which we already did. I guess we already did that one. Hey, we're one down. And let's also create 10.1.7.0/25 and 10.1.7.0/26 and 10.1.7.0/27. So we'll create those 4 new routes, and all of them, if we point to R6's FA 4/0 interface as the next hop, they'll all work. But the question is, which one will it use? And the answer is always going to be the router. If these are all viable routes, they all match a packet. So PC8 says, I'm going to ping 10.1.7. Let's go ahead and ping PC7, which is 10.7.10. If we do a ping to that address, the router gets the packet. All these 4 routes match, but it's going to use the one that has the longest match. In this case, it's going to be this bad boy right here. It's a 27-bit route, but I'll show you how to calculate that, and we'll walk through it together. So let's create those 4 static routes on R8, and then we can walk through the process of actually configuring or verifying which route is going to be used. So we'll make a road trip back to R8, and on R8, let's just do a show IP route static. I want to see what we have first. Not a bad idea before we start configuring. So we've got our 1 static route already. Great. And oh, hey, I have an up arrow key, and I'm not afraid to use it. So let's go ahead and create some new static routes. And that is IP route 10.1.7.0 with a 24-bit mask. And if we did our binary table and we put in a 1 bit for the mask in the 4th octet, come see me in Subnet Saturday, well, it would be a 128. Boom. And if we did it again, and we had a mask that was 2 bits in that 4th octet, it'd be 128 plus 64, and that would be 192. Boom. And if we were going to 24, 25, and if we were going to do a 27-bit mask, which is 3 bits on that last octet, the mask for that last octet would be 224. And so the binary and the decimal for that, I leave to your discretion in the Subnet Saturdays. I think you'll enjoy it, and that's what this means. Now, I have a question I'd like to ask you, and then we can look at the results. And that is, are all these routes getting into the routing table? I mean, earlier, we created a route, and we had like an administrative distance of 109, and then 110, and then as we put those in, it was overriding the previous ones. So here, I've put in 4 routes, well, 3 additional routes. The question is, aren't they the same network? Is the routing table going to treat them differently? And the secret is, they are not the same routes. The one we did earlier is a 24-bit route. Then we did a 25-bit route, and a 26-bit route, and a 27-bit route. And so all of them, because they're different routes, are going to make it into the routing table. At least that's my hope. Let's check it out. Let's do a do show IP route. And let's go ahead and just say static, because that's what we want to focus on. Here's our static routes right there. All 4 of them. 24, 25, 26, and 27-bit masks. So if we were to go to PC8, let me show you the topology. And let's imagine that we're over here at PC8 and we ping 10.1.7.10. Which of those routes is going to be used? And one way of just finding out from the router, which is pretty cool, is we can do a do show IP route, and we can put in that IP address of 10.1.7.10 and press enter, and it tells us, here's what I came up with. I've been working on this all night, says the router. It's showing us right here, it's using the /27. Why? Why the /27? All of those routes match, by the way. Every one of those static routes could have been used. I mean, they were all matching on the first 24 bits, first 25 bits, first 26 bits, first 27 bits. They all matched, but it chose to use the longest match. And so I thought it would be an entertaining game for us to play the game. How do we know which IP address is going to use which route? Because there's got to be some networks, I think you'll agree, let me go to the big camera. There's going to be some destination IP addresses that don't match that 27-bit network. And there's going to be some IP addresses going to 10.1.7. something that don't match the 26-bit network and the 27-bit network. And that way they would have to use the 25-bit network or the 24-bit network. And I'd like to share with you how you can calculate that and get it right every time. Let's do that right now. We're going to start off by, I need to get out my pen. And let's start off with this what do we want to call it? We want to call it, it's really the powers of 2, but the values for an octet of data. So 1, 2, 4, 8, 16, 32, 64, 128, 1, 2, 3, 4, 5, 6, 7, 8. Checking my work. There's a period there. Everything going that direction represents the 3rd octet. Everything going this direction represents the 4th octet, because we're starting to slice and dice in that last 4th octet. So if we were going to take these routes, and I'm just going to put the /27, and then we'll put the /26. And the /25, and the /24. So there's our masks. My question for you, for those of you who have been with me in Subnet Saturdays, or you just know this because you've been working in the field, I am so impressed. There are so many amazing people on this channel who have volunteered to help moderate the Discord server, who have volunteered to help answer questions and help their fellow humans. It's amazing. So my hat's off to everybody who's volunteering their time and talent and effort into helping other people. So regardless of how you might know it, Subnet Saturdays is certainly one of them. I'd like us to write out what the block size is for a 27-bit mask, and I'll put right here block size. What is the block size for a /27? What is the block size for a /26? What is the block size for a /25? And block size for a /24? And I'll go ahead and just circle those here. And what we could do is say, well, for a 27, if the 24 bits ends here at this period, and then we have 25, 26, 27, the block size would be 32 right there. And for a 26-bit network, 24, 25, 26 would be 64 right there. Great. So far, so good. For a /25, it would be 128, this bit right here. That's the least significant bit of the mask, 128. And for a 24, oh, we got to go back one because we're now in the third octet, and that least significant bit of the mask is a 1. Let me erase that real quick. Is a 1, and so the block size here is just going to be 1 in that third octet instead of the fourth, because that's where that belongs. So if we were to calculate, and here's the network 10.1.7, for the /27, let me put this in a slightly different color. It would be 10.1.7.0/27. And let's do the /26. 10.1.7.0/26. I'm starting slow. And 10.1.7.0/25. Just these are the routes right here. And then 10.1.7.0/24. So how is that going to help us in identifying, based on the IP address that's being sent, which route is going to be used? Hold on to your socks, because this is going to be one of the easiest things to do with the block size. In this network right here, 10.1.7 with a 32-bit block size, the next network, which I will put in a slightly different color, let me go ahead and use red here. The next network is going to be 10.1.7. plus the block size, 32. And I'll put a line there. For the 10.1.7.0.26 with the 64 block size, the next subnet is going to be 10.1.1.7. And we add the block size, 64. And for the /25, I separate that. For the /25, the next subnet is going to be 10.1.7. Add the block size. That game never gets old. It just keeps on trucking. And the benefit of doing this is because now we can identify the ranges of IP addresses for those subnets. Like lickety split, let's do it together. So on this network 10.1.7.0 with the 27-bit mask, the starting address is going to be .1. It's plus one more. For the first, so the network address you can't use as a host address because it's the street name. And the first IP address will be .1. And then the last address is going to be one less than the next subnet. If the next subnet is 32, you can't run into that space. So it'd be through .31. And I will say, for this discussion, that /31 is definitely the IPv4 broadcast address for the subnet. So really, we could only assign .1 through .30 to hosts, but that's the range of addresses that belong to the subnet. All right, next one. A subnet that has a /26. The first address is going to be, well, if it's .0 is where it starts, it's going to be .1 again. And then the ending address is going to be one less, or the range is going to be one less than the next subnet. So it'd go through .63. Again, 63 being the broadcast address for 10.1.7.0/26. And then, as we continue to go down here, this network with the /25, the first address is still going to be 1 through, and then the next subnet's 128, so you back that off 1, and the last IP address of that range for that subnet is 127. And again, these three on the far right are the broadcast addresses. So for this bad boy, 10.1.7.0, his block size is 1, and it's in the third octet, so the next subnet, and I'll put that in red just to make it consistent, it would be 10, that's not red, Let me see if I can do better. I can do better. 10.1.7, excuse me. The block size is 1 in that third octet, so 7 plus 1 more would be 8.0. And that would also make the range for this address be .1 through .255. And that 255 is definitely, once again, the broadcast address for this subnet. So let's talk about what we've done here. We've identified that the router, when it gets a packet and looks at its routing table, it could have potentially multiple routes that made it to the routing table, but which one is it going to use? It's going to use the one that has the longest match. So if we sent a packet from PC8 and we sent it to 10.1.7. Oh, let me take off my face. Sorry, you probably want to see that. If we have a packet that PC8 is sending to 10.1.7.10, which is the PC7 on the far side off that network, that address, .10, it fits in all of these. And as a result, this router is going to use the longest match, which is going to be the /27. If we were to send a packet to 10.1.7. Let's pick something higher than 31 and under 63. Let's go ahead and do 60. And I'll put here, it's going to use the /27. If we send an IP packet to that address, the router would look at its routing table and say, oh, .60, it doesn't match on the 27-bit network. No. But the next longest match is this bad boy right here with the /26. So it would use the /26 route. And if PC8 were to send a packet to 10.1.7. And we'll pick something up higher than 63, let's say 90, the router would look at its matches. It would have two matches. They would be the 25 and the 24-bit network. It would choose the longest, so it would be /25 route. Would be used again. And then for the last one, 10.1.7. Let's go ahead and use something higher than 127, something less than 255. Let's go ahead and use 200. That's in that range. And that would use the /24 because my friends, it uses the longest match it has when it gets an IP packet. And with the benefit of SEF, Cisco Express Forwarding, and caching, it makes these decisions, and also does the re-encapsulation at layer 2 and forwards those packets with the appropriate frame information as well, very, very, very fast. So I don't know. I just think that maybe we should try it and verify based on those 4 addresses, verify which routes are actually used. And then that can help cement that information in about, oh, I get it. It's the longest match. And as you become better with subnetting and calculating subnet ranges, which we're doing in Subnet Saturdays, you'll be able to do this whether it's in a production environment or at a certification exam or just as a freaking party trick to impress your friends. All right, let's test this out. I'm going to leave this screen up. I am going to use a little button magic here so I can work on the underlying screen and leave that up. And let's do a show IP route. And let's pick on we already did the first one. In fact, let's hit the up arrow key. That's 10.1.7.10. And this should be, based on our calculations, this should be using the 27-bit route. And we'll press enter. And there it is. Okay, 1 down, 3 to go. Next one up. Show IP route for 10.1.7.60. So we'll just back off the last octet and put 60 and press enter. And what we're expecting here is because that 60 is no longer in the range of the /27, but it's in the range of the /26. That's the route it should use because that's the longest route. And I'm not going to lie, I was hoping that would work. I was like, please let the math work here. And it does. All right, and let's go ahead and do the next one. We'll hit the up arrow key. And this time we'll ping 90, or do show IP route for 90, which is showing us the route that would be used. And 90 doesn't fall in the /27. It doesn't fall in the /26, but it does fall in the /25 and the 24, but the /25 is longer. So we're expecting the /25 route to be used for forwarding packet to 10.1.7.90. Sure enough, /25. One more, and that is a .200. And because the .200 it doesn't match the /27 or /26 or /25, the router is saying, oh, this is easy one for me. I only have one match here, and it is the /24. So we'll hit the up arrow key. We'll back off that last octet, type in 200, and press enter. And there's our 24-bit network. All right, I'm gonna be just straight up honest. I'm super happy all that worked. After the proxy ARP thing the other day, it's like, oh, come on, that's not fair. It's just trying to demonstrate a simple principle, and proxy ARP is kicking my rear end. All right, that is what I wanted to cover in the live stream today about why does a route have to win twice? Here's the summary. It has to win once to get into the routing table. And if there's conflict, meaning I have lots of sources, static routes, dynamic routing protocols of various flavors that are trying to get routes into my routing table. There's only so much room at the top of the podium, at the winners table. And that winners table is the routing table. And if there's conflict about the same exact network, it's going to go ahead and use the one with the lowest golf score, also called administrative distance. If the administrative distance is the same for these two routes, then uses the one with the lower cost. If the cost is the same for both OSPF and, well, I'll focus on OSPF. OSPF is going to put those both in the routing table and use those as equal cost paths for multipath routing. Now, once all the routes get in the routing table, which ones get used? If a packet comes in, those packets do not have any information about masks at all. All it is a 4-octet IP address. That's it. And so the router says, okay, let me see if you match anything I have in my routing table. And it looks for, if there's multiple matches, it's going to use the longest match and forward that packet. If there's no matches for explicit routes in the routing table, but it has a default route, it'll use the default route to go ahead and forward that traffic. And that's how it works. Yeah, pretty tickled it worked. Actually, I thought it would. I've done this a few times in my career, but it's always nice to see it again in a production environment and see it work. Okay, so here's what I'm going to do. I'm going to take a short break just for a few moments, and I would encourage you to grab a drink real quick or something else. And when we come back, I would like to go and do Q&A, and here's my request for Q&A. If you have anything related to what we covered today, about how routes get in the routing table or which routes are selected, although I think we've covered it. If you have any questions about that specifically, please let me know about those questions first. And then secondly, if there's any other questions regarding CCNA related topics, let me know. I also have a Discord server that I've had a lot of support for being moderators and people just volunteering their time. Way to go. 2 thumbs way up. And so if you want to join that as well, I've got 6 categories for suggestions. 1 for each of the domains for the new CCNA 200.301. And that way, if you have recommendations like, oh, I'd love to see this or this in the right topic, I can kind of verify what is wanted the most and then focus on that and make sure we include those in the live stream. So the format I'm intending on is for Subnet Saturdays, we're going to keep going until that is like a nice complete library. And for CCNA Sundays, going to keep going that until all your requests that match the blueprint have been done. And then after that, we'll come up with something else creative. But that's my objective, is to focus completely on CCNA and help people who are working on their CCNA or even Network Plus, because there's a lot of the same concepts, in doing well and improving. Okay, that's it. So also, when you ask questions, to save me from scrolling all the way back up, I'm a one-man operator here. If you had a question you asked earlier that you'd like to ask me, if you could ask it again now with an @Keith Barker, and that way it'll show up in a bright color for me so I can see it, verify it, and make sure I get to those questions. I know I've seen, holy schnikers, I have seen in the corner of my eye so many questions being answered by so many people. I am so grateful. CCNA is worth it. It is. If I look back on my career with Cisco systems and the things I learned, the skills I have with Cisco, it's all been worth it. And right now, I'm on a new learning curve with software-defined networking. APIs and using Postman and DNA Center and authentication tokens. And that's going to be my world for the next 3 or 4 months, just ramping up on all that stuff as I'm involved in a lab, or 2 labs at Cisco Live in June, where I'll be one of the proctors on those labs to help people who are brand new to it understand it. So I've got a few months to really jump in and master that content, while at the same time making CCNP content at CBT Nuggets, which is what I love to do. That's my full-time gig. All right, I'm going to go ahead and step away just for a few moments. I'll be right back, and then we'll go to some Q&A for a period of time, as long as you'd like to hang around. All right, thanks, everybody. I'll see you in a few minutes.
Life is a winding road, no telling where it goes. Driving through days and nights, won't stop for traffic lights. And I really wanna know if I'll ever figure out where the road goes. falling down, I will keep on searching for my highs. You can say I lost my mind, I will keep on holding my head high, even if the sky is falling down.
All right, I am back. If there's any questions, my Q&A screen is right here. So if I'm looking there, I'm looking at those questions, and I would be happy to take any. If there's no questions also, that's also very, very cool. I have a link in the notes right or below the video. It's going to be posted. It has the invite for the Discord server. So if you'd like to jump on that and join us there, we'd love to have you. It's a great place to make requests and also to discuss, and just check out the rules channel before you jump in and make sure you're comfortable with the rules and what the naughty list is all about, and avoid those things, and you'll be great. Okay. All right, Office to Crazy is asking, what is ping from interface? So I could elaborate on pings. So in IPv6, so if you would clarify that, Office to Crazy, for me, and I will be happy to elaborate on the correct answer. If we're doing a ping with an IPv6 address, with a link local address, we have to specify which interface, because link local addresses aren't routable. They're just off of an interface. So you have 3 interfaces on a Cisco router with IPv6, and you do a ping to a link local address. It needs to know which interface you want to ping from. There's also options for pinging where you can ping, and if you don't put any options, it's going to ping from the routing table from the closest interface to the destination. But maybe we have a client network behind us and we want to source a ping from that interface. So we can do a ping from so if we have gig 10 here and behind us gig 00 to our clients, we could do a ping out that way, and we could source it from either the IP address or the interface of gig 00. So those are 2 interface options for pings, actually 3. If that answers your question, that is fantastic. And Sophian is asking, did I put all the routers in area 0? I believe I did. Because this is CCNA, I did. I use a script. So earlier, let's go take a look. Earlier, and this is still here. I'm going to hide that for a moment. I'm bring my mic over so you can hear me. So if we do a show, well, this is a great way. Show IP OSPF database. That'll help confirm it. Yeah. So this is area 0, and I've got router LSAs from all 8 routers, which is a very quick way of confirming that all these routers are in OSPF area 0. And in the script I used, which is right here, also confirm. Oh, I erased it. So earlier, when I dumped them all in, I put everything that began with the 10 inside of OSPF area 0. So great question, and yes, I did. In CCNP and other higher level certifications, we would split those up into areas. That way, not every router doesn't have to have the full database for the entire network. You can just have the LSAs synchronized for the area it's in, and that makes a huge network more manageable from an OSPF perspective. We can also do summarization and filtering at something called an area border router. Okay. Dino's asking, what was the TCP traceroute tool you mentioned? How does it work? So in this environment, let's go back to this is a virtualized environment that my playground that I use quite a bit. It's also one that we use at CBT Nuggets. And these are just little virtual machines. And if we want to do a trace from here, and I'll just press enter. So trace without anything is, on this virtual machine, is just giving us options on what we can do. So by default, this uses UDP at the transport layer, layer 4, when it sends a packet, basically, to a destination that we specify. And then it sends 3 packets out with a TTL of 1. They all get rejected by the first hop router because it says, oh, the TTL expired. And then it does it with a TTL of 2 for 3 packets, and then it does it for a TTL of 3. And that's how we're mapping out the whole network. Each router is like, oh, I killed your packet. Second router, I killed your packet. Third router, I killed your packet. And in the background, that's what's happening. And at layer 4, it's using UDP. This machine, this virtual machine, this little teeny itty bitty virtual machine, really thin, has the ability to use ICMP. So if we did I'm on PC. Let me go to PC8. That's where we did our trace before. So if I went to PC8 and I'm going to do a trace and just press enter to get a little context sensitive help here. So the syntax is trace, the destination, great, and then the option. So if we did a normal trace like that, it's using UDP. The end device, oh, it didn't care. 57. Okay. It didn't bark. It's using UDP by default, but this time it didn't complain about port not available. Let me ping to 7. That's the interface address of R7 on the far left-hand side of our topology. Yeah, it doesn't like it. So the actual PC just said, oh, whatever. And this device, the router, is saying, I don't have that port open, whatever that port was. So that's what this port destination and reachable message is. If we did this, I'm going to get my context-sensitive help again. I'm going to hit trace, and then we do that same command again to 10.1.7.7, and this time we do a -p, and then we say protocol 1. That's literally the protocol number for ICMP. So TCP is protocol 6, right there in front of me, and UDP is protocol 17 in decimal, or 11 in hex, depending on what you're looking at. And this says, please use ICMP. And so from the end device, it just looks like a ping request. Instead of looking for a UDP random open port, it actually looks like a ICMP echo request. And then the router says, great, nothing to do here except respond with the TTL expired message. So Cisco routers use UDP by default, and Windows computers, they use, and Linux uses UDP by default, and Windows uses ICMP. And I think there's an option. If we went to a router, let's go to R8, and on the router, if we do a show, not show. If we do extended ping, no. If you do extended trace route, yeah, just give me a chance to think. I rewatched my stream from yesterday, and that's what I was doing with proxy. I was watching myself think through the solution, like what the heck is going on here? So if we do trace route and press enter, that's going to give us an extended trace route. So we're using IP, target address of 10.1.7.10. That's the PC on the far left-hand side of the network. Enter. Source address. So if you want to source it from a different interface, then let's take a peek. Then this /1 interface right there, we could source it from gig 00 if we did, but by default it's going to use the closest interface towards that destination based on its routing table. So we can leave that alone. So I'm going to press enter. Numeric display, that's fine. Timeout, probe count, time to live. Port number. Okay, so this is asking us, okay, for UDP, for your trace route, what port number do you want to use? So I was thinking there might be an option for TCP or ICMP, but it appears that it's just port number. Yep. So there you go, and there's our trace. Come on back. All right, and it timed out. That's what the asterisk represents. There are some great hacking tools that can do trace commands that you can throw in specifically, ICMP or UDP or TCP, and I would just do a quick Google search to find some of those. Also, if you're going to use hacking tools, please don't ever use a tool like that on a production network that you don't have explicit permission to do it, because that could be considered a violation of security for most companies. So any hacking tool, play with them at home, practice them at home, or on networks that you're authorized to practice them on. Scapy is one of the tools where you can send almost anything you want with any kind of configuration. I've used that in the past, and Kali Linux just has a boatload of tools built in. All right, so I think hopefully I answered that question, and let me take a look at any more. Okay, can you please explain how to configure IPv6 on a Cisco router having first 64 bits from the ISP? So you could have one big network. If the ISP gives you, the ISP may give you a block of addresses where you'd have thousands or hundreds of thousands of subnets or networks to play with. But if they give you one IP address, you could do subnetting for that. So what I'd like to do, if that's something you're very interested in the Discord channel, go ahead and put that in. There's 6 sections for CCNA suggestions from you. That's what it's for. And if you just put that in as a suggestion, that's where I'm going to go almost every week and look through and say, okay, what is the common theme, or are people upvoting this? What do people want to see from a CCNA perspective? And that's what I'll focus our next streams on. So if you do that for me, I'd be happy to prepare something formal for you and then walk you through it. And Office to Crazy saying, Keith, can you elaborate? And because I don't I don't remember what the first part was, you'll need to type that in a little bit further context so I can elaborate on the right thing. All right, some great responses from the community. I appreciate that. And let's take a look. Is there a possibility to go through the feasible successors and how it works and go deeper than just the theory about it? I love the feasible successor. Unfortunately, it's not part of CCNA anymore, so it won't be on this channel. Yeah, I want to focus. I want to make sure everything that I'm saying and doing and helping with is driven for CCNA. But I'll tell you what, we should make another channel on Discord and have it say other topics other than CCNA. In fact, to my list. And then I can take that, look at that, and just not lose them. I can have that history of what people want, what they're looking for. And then if I run out of every possible topic in CCNA, which I don't think we will for a long, long time, then we can go ahead and tackle some of those. So if you'd make that recommendation, let me get that channel added to Discord, like other recommendations for topics. If you could add that, I'd be happy to consider that once we get the CCNA mostly out of the way. Thank you, Cisco Cybertech, for that recommendation. And let me see here. Okay, Ayer I hope I'm pronouncing that right. Ayer, I think you explained how to pronounce your name, and I think I did it correct when you explained it, and I hope I'm doing it correctly now. But I love you. Ayer. Thank you for your great work. One of the things Sufyan, thank you very much for the super chat. Thank you for all your great work. One of the things I'm kind of struggling with is equal/unequal load balancing with OSPF and EIGRP. The great news about unequal cost load balancing is that OSPF doesn't do it. EIGRP can do it, but OSPF doesn't. OSPF is simply using equal cost routes, load balancing across those equally or fairly equally. The actual algorithm it's using is based on the type of flows going across it with Ceph, but there's no unequal cost load balancing with OSPF, at least that I'm aware of. Okay, Dan is asking, hey Dan, how do you trace from your virtual network to physical network on different subnets? I would follow the MAC address. So if we're going between subnets, how do you trace from virtual network to physical networks on different subnets? If we do a trace, not every router or firewall, if I'm configuring it, is going to be willing to respond to the TTL expired. A good firewall isn't going to give you that information. I shouldn't say good. Many firewalls, when they're configured, are trained, hey, that TTL expired, I'm dropping the packet. I'm not telling the hacker anything because they're trying to figure out the path through the network, perhaps. So we might get timeouts, but assuming that every device in the path that's a layer 3 routing device, which could include firewalls, if they're responding when the TTL expires and they send back an ICMP message to the source saying that we killed your packet, that's literally going to show you each of the hops through the network. So each router interface represents a different network. And so that would be representative, whether you're using multi-layer switches or physical routers, that would be representative of the path it's taking based on the routers that respond back to you with exactly who those hops are and where they're coming from. All right, Frank passed his CCNA route switch before the exam change. Nice. Wow, there's a lot of people pushing it at the last moment, and I'm happy for everybody who succeeded. That is fantastic. Okay, Porter4E is asking, based on the router choosing the longest match to route the specific. So routers, when they're making a routing decision, they're not really considering subnets. It's like a blind decision based on the routing table. So you could have, like we did, we created 4 static routes that really pointed to the same area. But when it's looking at the routing table, it's just considering, okay, here's the destination address, which of these routes match, and I'm going to use the longest one. Actually, what it says is, here's the destination address, here's my match. It's the longest route that matches explicitly. I'm going to forward. So based on the router choosing the longest match to route traffic, would there ever be a time when the longest match is not met? There are some corner cases. That's a great question. If we're doing policy-based routing, where we're simply telling the router based on these conditions, do this, that would certainly exclude it from choosing the longest match on its own. With OSPF, there are some really interesting corner cases on OSPF types, but they would be different networks, so I take that back. A longer match, I believe, unless you're doing policy-based routing or have other controls in place, I can't think of an example where the longest match would not be used if the longest match matched the packet coming in. Could be wrong, but I don't think so. I think that's exactly how it works. And Frank is asking, what's your view of Viral? I don't. If that's for me, I'll answer it. If it's for somebody else, I apologize. Viral is a great tool. Version 2 is coming out for CCNA. All you need is Packet Tracer. It is free. Go to netacad.com, sign up, get a free account, download Packet Tracer, start having fun with it. It's fabulous. So for CCNP level stuff, it's actually quite useful because it can do a lot of things that Packet Tracer cannot. So my opinion of Viral is it's $200. I own a license for it. I don't use it all the time, but I have it in the event that I need it. Oh, Keith, can I give you the Discord link? Yes. Yes, I can. Let me go ahead and grab that. In fact, if I could have one of the somebody who's on YouTube right now, for this page in the messages below, I pinned a comment with that link, so you can go to there. Or if somebody wants to grab that and just paste it into chats, that'd be awesome too. Either way, that'll take you right there. Thank you for asking. I'm new to Discord. I was going through the security and I was like, I had a few questions and I built the server and I hit a clear settings, clear permissions. I thought, oh, I don't know if I... So anyway, long story short, I spent many, many hours building, tearing down the Discord server. And I'm still getting feedback from the moderators, thank you very much, on things that, hey, people can't see the rules. Oh, that's me. And going in or, oh, hey, as a member, I can only add one comment every 5 minutes or something. And I had accidentally put on slow mode for one of the channels. So learning experiences. Yep, learning. So I'm grateful. And we'll get it all dialed in. It's going to be wonderful. What book would I recommend for CCNP Encore? The way I do books is, if I've read one and I had a recommendation, I would tell you. I currently have a subscription for like Safari Online, or maybe now it's O'Reilly or something else, that gives me the electronic access to the books. The one that I use is the cert guide, the official cert guide for CCNP for Encore. So I would use that one. Also, if you go up to Amazon, even if you don't buy it from Amazon, depending on your feelings about that, but I buy a lot of stuff from Amazon. They're so convenient. But go to Amazon, do a search for books for Encore, maybe put the exam number in, and then see which ones are rated. I really enjoy looking at the ratings, including the ones. People who don't look at 1-star ratings should, because if you have like 90% of 5 stars and you have one for 1 star, or a few for 1 star, you can just look at those and say, oh, why is this person disgruntled? Or why is this, find out what their thing is. And maybe they wrote the other book and they're competing or whatever. But if most people love it, and there are people who bought the book and there's more than just like 5 evals, ratings, I would trust that. So if they had like 50 or 100 ratings on a book and there are people are saying, yep, it was concise, it was well done, et cetera, that's a good decision point. And that's just a flexible answer that can be used on any new decision for a book. But I usually go with the official guides. I find them very convenient. Not always. I've written some books for Pearson Publishing and Cisco Press many years ago, and it's tough. There's a lot of information that goes in there, and hopefully everything's fact-checked. And sometimes I'll see something, I'll read something, and I'll say, that's not how that works. Occasionally. So I don't have any specific examples, but I have seen one in the last week or two. I've seen a couple like that. It wasn't gross errors, just little things, and it happens. And so I would give the authors, if it's a generally great book, I would give them a lot of kudos. So this shirt says, I've got your back. That is a question that just came in, so that's what that is. I have another shirt that says, I wear this shirt, periodic table shirt, and it says, I wear this shirt periodically. I like the humorous shirts. My wife thinks they're corny, but they're part of me, and she loves me, so I'm all good. Thanks for the question, Dino. Okay, if you wanted to be a moderator and didn't get a link and you still want to be a moderator, contact me at that same email address, contact@thekeithbarker.com, and express the desire to still be a moderator if that's what you want to do, and I will go through those sometime in the next 4 or 5 days, and I'd be happy to add more people who want to help and serve. So if I missed you or if I didn't get to you, please give me another opportunity to get you into the fold and add you as a moderator if you'd like to be. So thank you for that question. Okay, another question. Can you provide Discord details? I'd like to join. In addition to this channel, you'll be focused on Cisco CCNA 200-301. What about the new CCNP? Great question. This channel is going to be focused on CCNA 200-301. Hard stop, period. And that's because there are, I believe, tens of thousands of people a month who are in some stage of preparation or wanting to learn more about CCNA. And I'd like our channel, I say ours because you're doing an amazing job of contributing. I would like our channel to be synonymous with, if you're studying for CCNA, you got to go through the playlist from Keith, and he's not monetizing it. There's no ads, at least at this point. Unless something drastically changes, that's not going to change either. He's there to help. He's telling the straight scoop, giving examples. You can watch him troubleshoot proxy ARP when that shows up. And I would like us to be synonymous with CCNA 200-301, and I'd like your help to do it for no other reason than helping our fellow humans. So once you get your CCNA, come back, stop by occasionally, answer some chats in Discord, make recommendations on topics you'd like to see for CCNA, and that is going to be the focus. It's important to have. I love CCNP level stuff. I love CCA level stuff, but I'm focusing this channel 99.8% on CCNA. Keith, are you going to go over, this is from Office to Crazy. Keith, are you going to go over automation on this channel for the new exam? Yes, I am. And it's going to be probably a couple months down the road because I discovered something interesting. If a person wants to teach something clearly and really explain it so a person can get it, including examples and demonstrations to really help that information sink in, they need to know it first. And I have been on the cusp of automation for a long time. I mean, I saw it coming. I knew it was coming. I understand SDN, how it works, but I had never taken the time to actually study it in depth, which is what I'm starting as of last week. So I'm going through the content, the videos, the DevNet, using dCloud, using Postman. I'm having so much fun with Postman. Postman is a tool that you can use to test and work with your APIs. An API, in the old days, and this demo, well, the way we interacted with our devices was one-on-one with the console cable first, and then maybe after we give it an IP address and a default gateway, if it's a switch, or an IP address on an interface and some routing information, we can connect to it over the internet or over a network with IP using SSH from a terminal emulator, one device at a time. Configure, 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 configure. So that was our interface of how we worked with those devices. To deploy hundreds or dozens of devices, it takes a lot of time. So instead of having us as humans interact with those devices, we have a controller that interacts with those devices. And the language of love between this controller, think of a controller like a machine, a computer, that is communicating with your switch or your router, your firewall, or other network device. And instead of using a console cable, or instead of using like Telnet or SSH, it uses this special set of commands or special methods called API. So all an API is an application programming interface. It's the agreed to method for sending data, receiving data between a controller and the network device. So where do we come in as administrators? Well, where we come in is we sit at a console or we sit at a computer that has a beautiful interface where we can do intent-based networking, where we're just saying we want this to happen, we want that port to be open, we want this flow of traffic, and then behind the scenes, we're using orchestration software that's making sure all that happens. Like if something goes wrong, in the background, scripts can be run and find out information and provide us an overview of what's going on, and that's from the controller. So the controller talks to the network devices, the controller talks to us at our management interface, and that's software-defined networking. And it makes a lot of sense. But the key is with CCNA, they want you to be at a very high level, just aware, like what I just explained, of some of the concepts of that, understand JSON, which is not hard to recognize it and what it does and why it works. And that will help prepare you if you want to take the next steps into automation, or you're working in an environment where they have automation, you'll understand, oh, yeah, I get it. We're not logging into each of the devices with the console. We're not logging into each of the devices with SSH, with the terminal emulator. We're going to use some kind of an orchestration software, that a management console, that where the controller is talking to and pushing commands and working with these network devices. And we, through a graphical user interface, usually are going to be talking to that controller. And then behind the scenes, when the whole thing goes to, we need to understand some basics about the APIs, the language of love, whether it's Python and using YAML and other methods to actually communicate. So yes, the answer is, when I become more ready to do a very clear job of describing at the right level for CCNA those pieces, we are going to have some live streams on that with demonstrations. So thank you for that question. I'm excited about it too, by the way. I had I had a manager many years ago named Ted, and he was telling me about, I forget how the example came up. Oh, he talked about change and learning, and he said when he played football, or he gave me the analogy, when somebody plays football, like in high school, there's going to be some pain involved. And the best way to get through that pain is embrace it, realize it's going to be there, and just work through it. And the same thing is with anything new in life. You want to play the guitar or the ukulele or the radio, that's a joke, or learn something new about networking, or get your skills in the world of automation, or at least be aware of it. There's a little pain involved, but it's worth it. And so if you can find somebody to help ease the skids, grease the tracks, and help you get into that nice and comfortably, which is what my intent is on this channel for anybody who's pursuing CCNA, that's a good thing. And then you can basically understand the concepts, and then you can appreciate more of the details. And then if you want to become most network engineers are not going to become programmers, but understanding how the Python scripts are working and some of the tools that are used, that'd be important. So the answer is yes, it's coming. Let me see, what else do we have? Are you planning on creating content for CCNP? So anything CCNP related on this channel is not going to happen. It's CCNA exclusively on this channel. At CBC Nuggets, we've got Jeremy, Network Chuck, Jeff Kish, Knox Hutchinson, and others who are working on the libraries for the CCNP stuff. And that's a paid service. There is a free trial if you want to check that out. But those are in process and going, and I'm saving all that CCNP level stuff for CBT Nuggets. So who knows, in 2 years, maybe we'll make another channel for CCNP. But once, I want to make sure the CCNA is all buttoned up. And Joe is asking, did I take the CCNA already? No, I have not taken the CCNA already. I will. Network Chuck took it, Network Chuck took the DevNet, I think on Monday. He passed. Knox Hutchinson took it, and I thought, okay. First of all, I need to brush up on my network automation and programmability, and then once I do that, I'll look at the blueprint. I'll take the same advice I've been giving, and that is, look at the blueprint, go through each item, ask myself on a scale of 1 to 5, how well do I know that? If I'm a 4 or better, I'll go take the exam. If there's something like I'm a 2 or a 3, I'll spend a few hours brushing up on those topics. If there's a lab item that says configure, I'll make sure that I know how to both configure and troubleshoot that technology. There's not too many like that, by the way. And then go take the exam. So I will be taking the exam, but probably not for a month or 2. All right, still going down the list. Okay, Justin saying, I found more free content. Do you want to add it to newer videos or the one where you ask for support? So I've got on the Discord channel, I think that'd be a great place to collect all that. And so some of the rules for the Discord channel are that any post that we do, there's no harassment of any type and all those normal things, but also no sharing of any paid training content. So no brain dumps, no stealing other, no content that's paid for somewhere else, nothing like that. But if you have free content, Justin, let's go ahead and put it in Discord. And if there's not a channel yet for it, just go ahead and make a recommendation, and I or one of the moderators can go ahead and make that channel, and then that would be great. And we'll name it something like additional free training. And maybe I'll make a special channel that's we'll figure out a great way to do it so it's easy to find on the Discord server. So the Discord server, I'm pretty impressed. It's pretty amazing. Pretty good to communicate. And Sufyan, can we use the Cisco AeroNet 3700 AP connected to a home router to act as an AP? If it supports, I'm not familiar with that specific model off the top of my head, but if it supports autonomous mode, which is the AP does all the brains and thinking on itself, yeah, you could use it as an access point to do all the normal access point things. If it doesn't support that, if it supports lightweight only where it needs a controller, then it wouldn't be too successful. So it depends on if it supports autonomous mode. If it does, you can just image it as autonomous mode or set it that way and then use it. I did that when I taught the Cisco CCNA wireless, which is no longer a test. But when I taught that, I used a virtual wireless LAN controller running on a computer. And then in the physical world, I had 3 access points. And I demonstrated in that CBT Nuggets course, I demonstrated how to change them back and forth to lightweight versus autonomous. Autonomous basically meaning you don't need to use a controller to make it work. All right, Dan, I don't know the answer to that question. So iOS on Unix, just to give you a heads up. So if you purchase a license for Viral, you get, you're licensed that product from Cisco. It's $200 a year, I believe. And IOU, which is the iOS on Unix, isn't officially licensed to Cisco has big partners that I think they give it to and allow them to use. But for the average human, iOS on Unix is not a legal or lawful thing. So for CCNA, stick with Packet Tracer, learn the commands, and be well and safe. Okay, let's see here. What about a security channel? That's a good question. That's from Ola Deji. A security channel might be good. The CCNA channel is probably going to take a few more months to fully bake. And then once we have a lot of people who are benefiting from it and coming back, I want all the alumni to come back. Don't forget about us. Come back, help other people, catch a stream occasionally, have some fun as you continue to progress in your CCNP. I want you to outgrow this channel. I want you to master this content and then just crush it and never stop. That's it. So come back occasionally and say hi. So maybe after this channel is all like, there's nothing else that can be taught. There's no demo that can be done. Everything's been covered. Perhaps we'll look at a security channel. But there's no CCNA security anymore. So the first security we're looking at is the core and concentration exams at the NP level. So we shall see. And VAIBHAV, thank you for the question. Which firewall certificate should I get after the CCNA? What I would do is if you are working in an organization or you think you might want to work in an organization where they're using a certain type of firewall, so if you go to dice.com or in the States, monster.com, it might be international as well, find out what they're using at the place that you would like to work, and then take a look at job requirements and what they want you to know about it. And I would focus on the one you're most likely to use. And if you're at a company that has a firewall, maybe they have ASAs, maybe start learning that. Or if they have Firepower, or if they have Checkpoint or Palo Alto, I would focus on using those, because what happens is if you learn the technology for a product and then you never use it, it evaporates after time. And so just to memorize it, to have it in your head for like a half a year or 6 months or a year, it may not be as beneficial if you can never apply it. So I would say go for the firewall that you're most likely to see, or the one that you can get hands-on practice. That's also a big thing. If it's like Checkpoint, they offer, from Checkpoint, if you get their CD, or download the image and as a CD image, and you can actually install it, and they have like a 15-day free trial, which gives a person an opportunity to practice with it and run it through its numbers, where other vendors, I'll leave them all nameless, don't make it so easy. So there's also that too. Which technology could I do the hands-on practice with, and there's three primary firewalls that are competing for the space: Palo Alto, Checkpoint, and Cisco's Firepower. So any one of those three would be good bets. All right, another question. GRE tunnels, Cisco to Cisco, and perhaps GRE tunnels, Cisco to Cumulus, Juniper, other, and top of. So if you would, I think. Oh, that's Encore. I'm looking at the Encore blueprint. Yeah, sure enough, GRE and IPsec tunneling. I don't know that that's on the CCNA blueprint, so let's go ahead and put that in the Discord server in the channel for other recommendations. And once we run out of CCNA level content, I would be happy to take a look at a few of those. All right, thanks for the request. It's good to have you, by the way. It's good to have everyone here. And I don't think CBT Nuggets has any Microtech training. Okay, I think we answered the one on the channel for CCNP security. Probably not for a long time. It's 1:30 a.m., says Office to Crazy. I got to go to bed. Awesome. Thanks for being here. I appreciate the sacrifice of staying up a little bit later or staying up early to be here. It's great to have you. And let me see if there's anything else. Can you explain the use of a null route and a good use for it? Dina, that's a great question. Let's go. Let me see if I have a live interface still. And if we do, I can actually demonstrate that. And, oh, I've got 3 minutes. Yeah, that's not going to happen. It says I have 3 minutes left on that lab. I set a timer for 2 hours, and I got 3 minutes left. So if we are doing summarization, which we are going to cover in Subnet Saturdays, but summarization is where we're taking like 15 or 100 networks, and we're advertising a summary route. So let's do an example of, let's do a gross example, a gross over summary. And let's say we have the following networks: 10.1, 16-bit mask, 10.2, 16-bit mask, 10.3, 10.4, 10.5, 10. etc., all the way up to 254. So we have all those 254 networks. If we created one static route that said to get to network 10. anything, like 10.000 with a 8-bit mask, that one IP summary network address, that one summary route is going to cover all the rest. So what we could do is, if we advertise that route, we could create a null route. One way of doing it, we could create a route saying IP route to get to 10.000 with an 8-bit mask. The next hop is null 0. That would be a route to null 0. It doesn't really exist. And then we could suppress all the other routes from being advertised. So we're basically telling the rest of the network, 10 anything over here. And once those packets come in, then the detailed routes that we have, we can actually use and forward the packets to those specific networks. But at the same time, if we get a packet for 10. Let's say we didn't have a real network for 10.28, didn't exist. If we get a packet for 10.28, because they're coming our way because we did the summary, the 10 summary route to null 0 is going to take that 10 because it doesn't match anything else in the routing table more explicitly, and it just kills it right there. So instead of trying to route a packet that doesn't belong, that doesn't have a destination that we have reachable, we can just drop it. So anytime we need to do a summary, well, not anytime, but doing a summary with a null route is one example of when we would use one, just to catch any stray routes that come in, any stray packets, and send them to the bit bucket. So null 0 is like the bit bucket. That is a null route and a good use for it. Thanks for the question, Dino. Office to Crazy. Okay, thank you. And Trust the Process. Thank you for your help in the channel, as well as everybody who's answering questions. And I think that's it. I think that's it for today's live stream. Next Saturday, which is just a few days away, we're going to be taking a look at Subnet Saturday and advancing on what we covered previously, which will also help reinforce some of the work we did today regarding those 4 routes and identifying the ranges for those networks, which would determine which would be the longest match in the routing table, which we had to do manually. But that was really an exercise in identifying subnets in the routing table. And awesome feedback. All right, so Office to Crazy, just to confirm that my focus here is going to be CCNA 200.301 and that blueprint and all things on it. All right. Rohit's asking, can null routes, is that possible in the ASA? I don't know. Let's find out. Let me Google that. Let me Google that for you. It's possible on a Cisco router. Let me go over here and let me bring up a browser. And I'll just leave the camera right there if that's okay. And let me bring this up. Okay, new window. Went on the wrong screen. And Cisco ASA null route. All right. So let me share my screen now that I have it up. And boom, here we go. So based on this extensive Google search that I did, Solved. ASA null route question. Cisco community. Solved. Hello. It looks like there are no null route function in earlier versions of ASA. Just checking today. When checking 9.x, it will have a null route. Now, how old is that? 50. Let me take a look at that note. So that's what I would do. I just look it up. Oh, that's from 2014. Oh, use the shun instead. IP route. I'm not getting the answer I wanted from this. Let's do that search again. ASA. Because I want a current version. So this talks about null routes, but it's not regarding an ASA. So that says it's an approximation. That's a great question. So I don't know the answer to that. What I would do is I would take the version of ASA that I currently have, and I would just go to the online doc and look it up. Because it looks like it may depend on the version, and it definitely appears that some of the older versions don't support null routes on the ASA. All right. Hey, thanks everybody for joining me for the live stream. It's so good to have you here. If you're studying for CCNA, we want you to be here. If you've already got your CCNA, we want you to come back here and help others. Join the Discord server. The link will be posted below. And if you haven't already subscribed, please feel free to do so. If you enjoyed parts of the video, click on the like. If you didn't like the video, my name is Todd Lamley. Just kidding. I've only met Todd once, and he seems like a really good guy. All right, that's just a joke. And then I will chat. I'll leave the stream running with a little music, and I'll answer that last chat directly with the chat message. Hey, thanks, everybody. I'll see you in the next live stream. Bye.
I've been waiting all my life for someone like you. I would watch the days go by, wasted and blue. I was out of use. Now every day, every night, every moment with you, I'm walking on air. And every day, every way, I feel I can't lose. I wanna shout it out, ain't no limit. I wanna shout it out to the world. You got me all worked up, got me spinning. I'm crazy for love, crazy for was out of use.